So now let us see question number 51. So question goes like, one end of a spring of natural length h, okay, and spring constant k is fixed at a ground and other is fitted to the smooth ring of mass m, which is allowed to slide on horizontal rod fixed at height h. Initially the spring makes an angle of 37 degrees with the vertical when the system is released from rest. Okay. Find the speed of the ring when the spring becomes vertical. So they have given a diagram like this. We have a ring, it seems, and we have a base. We have a base and we have a okay. So this is actually 37 degrees height h and spring constant k. This is spring constant k of mass m. So this is mass m. This is allowed to slide like this here and there. Okay. At a height h, initially the spring makes an angle 37 degrees, which is we have marked. Find the speed of the ring when it becomes totally vertical. Okay, so this is the calculation. So height h is given. Let's assume this is point A, this is point B. So for us to understand, so find we want to find the velocity when the spring is vertical like this. Okay, so this should be in dotted lines. Okay, velocity when the spring is vertical. Now let us put a trigonometrical values. Cos 37 equal to adjacent, which is h, by hypotenuse, which is the length of the length of the spring, right? So that should be equal to h, which they have given, and we'll have to calculate the distance of the spring. One end of natural length h is there. Okay, natural length h is there, so we need to calculate it. So that would be somewhere equal to cos h by extended length, which is del L. So h by del L is somewhere about cos 37 would be cos 37. So 0.8. Okay, so this is the first term which we could have it for our references. So now let us see the whole distance, which is del L, or assume it to be AC. So let's have a point C. Okay, AC will be more meaningful because del L we are not sure whether it is total length or del L and all those stuff. So avoid this confusion. I have it as AC. AC would be like h because that's a natural length and the extended length. So that would be h plus x, right? Natural length plus extended length. Okay, h plus n. So which is equal to, so 0.8, right? Okay, so 0.8. So 1 divided by 0.8 would be 1.25. So what we would do, so that would be 1.25 times the h, right? Because of the value we get, right? H by AC. So AC would be 1.25 times, because 1 by 0.8 would be 1.25 times the h. Okay, so once that is done, next step would be to find the x value. So because we have two relationships as of now, h plus x equal to 1.25 h. Okay, so we shall calculate x is gonna be 1.25 h minus h, so which is gonna be 0.25 times the h, right? So now we shall apply the conservation of energy principle. So which is spring extended energy half kx square equal to slides moment energy half mv square. So solving, I would get somewhere about solving for v, I should get half and half should get cancels, half and half gets cancels. So kx squared by m is equal to v square. So v equal to root of kx squared by m substituting the values, x is gonna be 0.25 h. So root of k by m, we can have it as such, x square can come out, so x is actually 0.25 h, or we can also write it as having a different color, root of k by m into h by 4. So this is the answer.